So good morning, good afternoon, good evening from wherever you are joining us. I'm Arash and welcome to this virtual open day. We start with an introduction of who is in the room and who is going to talk. So please.
Hello everybody, I'm Dr. Carmine Galasso, I'm an associate professor here at UCL and I've been the program director for this master for the past 5 years. I'm now passing it to Arash, that will be your new program director from September, actually from right now, but you will meet him in September.
Okay, so I'm Arash, as I mentioned. I'll be going, if you say, the current program director of MSc in Earthquake Engineering with Disaster Management. I will be talking about the course and introducing you to University College London a little bit, and then my colleague will continue the presentation. We will talk about 30 minutes, and then we will open the floor for any questions that you have so we can answer it. With me or...
Hi everyone, I'm Valentina. I'm an alumna of the same MSc course, and I'm now a PhD student at UCL in the same department, CEGE. And with me?
Hello, I'm Kieran. I'm a current student of the Earthquake Engineering and Disaster Management course. Previously come from working with the UN on a post-disaster reconstruction project, and that's what I hope to do after this.
Hello everyone, I'm a Chinese student studying in MSc Earthquake Engineering with Disaster Management, same as Kieran.
So I will start the presentation and hopefully everyone can hear us. The worst case scenario, if you can't hear us or you can't see the screen, we are recording this and this will be uploaded later for you to see as well. Again, we are always available to answer your questions even after this virtual open day. Yes, welcome to this virtual open day. As I mentioned, we're going to talk about less than 30 minutes. We're going to talk about University College London, the structure of the course, what is earthquake engineering, and then we'll get into more details of what is expected from you and what are the coursework, what are the tutorials, what are the modules, and what is the assessments that we expect from you. So let's start with why study at UCL. So if you don't know anything about UCL, UCL is one of the oldest universities in the UK. It was founded in 1826, so we are very close of celebrating our 200th year. It has more than 41,000 students, so it's a massive university. It's one of the biggest universities in the UK as well. And we have about 8,000 academic staff. So the ratio between the students and staff is in a very good position as well. We are proud of 40 Nobel Prize winners that we have. 29 of them are directly from UCL. 11 of them are either honorary from UCL or they have been working with us on different projects. Because of that and because of the great number of students that we have very famous alumni as well. For example, William Ramsay, which was the discoverer of the noble gases. Or you might know Alexander Graham Bell, which was the inventor of the telephone, or the father of India, Mahatma Gandhi, which was studying law at UCL. And my favorite one is Christopher Nolan. I'm sure you know him for the movies like Batman Returns, Inception. Actually, the main quote, the photo that you see in the background, has been recorded continuously in his movies. The main quad of UCL has been in so many movies. For example, it has been pretending to be movies like Inception. So UCL is continuously ranked among the top 20 universities in the world. If you check QS World Ranking or the Time Higher World Rankings, you can see UCL in the top 20 always. We are proud to be the first university which admitted students regardless of their class or religious. UCL was the first university in UK and England which admitted women on equal basis as men in 1878. We currently have 58% of students are women, so we're proud of that as well. In continuous assessments that UK does of its universities, for example, REF, which is the Research Excellence framework. Okay, sorry. Research Excellence Framework, which is like a World Cup of research in UK, which happens every 4 years. In 2014, the latest one, UCL has become the first on top of other universities, as well as on top of Oxford and Cambridge. And we are again proud that we are one of the most international universities in the world. Our students come from 150 countries, except the European countries, and we're proud that 1/3 of all of our students are from these 150 countries. So it's a very international environment. You might ask, okay, why study in London? So as you know, London is one of the biggest and most famous cities in the world, with plenty of attractions, museums, events, arts, restaurants, and shops. There is no way that you can be bored in this city. And this is not what I say, it's actually a fact from TripAdvisor. On the other side, this year, London has been ranked as the best city for students. London comes first, then is Tokyo, Melbourne, and if I'm not wrong, Melbourne, there's one other place as well. Let me check my knowledge. Montreal as well. So yes, London is number one, and then it comes Tokyo, Melbourne, and Montreal. So it's a very cool place. It's a very fun place. You will never ever feel lonely there. It's a very multicultural, multinational city as well. So it's a great place to study as well as living. But let's quickly get into what is earthquake engineering. So in the past descriptions, we had a very narrow definition of it. It was just studying and looking at the behavior of structures and geostructures when earthquake loading was applied. But nowadays we realize that it's a much, much wider discipline of civil, structural engineering, as well as other disciplines like social sciences, especially sociology, political sciences, economics, and finances. But the whole aim of earthquake engineering nowadays is to predict the potential consequences of that terrible disaster, both on the social side, economical side, and how the infrastructure that we currently have, like bridges, like roads, or residential, or critical infrastructure like hospitals and schools, will react under it. So the whole aim is to design, construct, retrofit, and maintain structures to limit this seismic risk in terms of economic and social to an acceptable level. Going to the next slide. So the course aims to train engineers. These engineers will have a good knowledge of seismology, soil dynamics, and structural dynamics in order to evaluate seismic risk. They're able to design structures, steel, concrete, masonry, timber, any of them, to the current seismic codes, as well as some novel advanced methodologies, which are not very common currently, but they will be in the future, So you will become an engineer which knows how to design for seismic, how to repair for earthquake loading, and how to assess structures against seismic loading. So on the other side, you will understand the national and worldwide social, economical, and political consequences of earthquake events, as well as other natural disasters like tsunamis, typhoons, volcanoes. And you will be able to select and apply the best solution for pre-event risk mitigation, as well as post-event risk management, in order to have the highest economical benefit and life safety effectiveness. Yes. We also have a unique combination of world-leading experts, both academic and industrial, which my colleague will be talking more about them as well. We will focus mainly on practical applications. So we won't waste any of your time. Whatever we teach you will be very straightforward, it will be applicable, and you will see these through the tutorials and the industrial seminars that we put for you, which how these topics that you will learn will be applicable in the industry as well as the research. So we will be uniquely target basic concepts, interpretations, and how to use equations, softwares, and tools. You will learn a lot of softwares. Some of these are shown on the screen as well, but your CV will be full of softwares which are related to earthquake engineering and seismic design. On the other side, we will try our best to train and develop your abilities and improve your skills. For example, we will work on your presentation skills. We will work on your group working skills. So through the trainings that we will do, we will deliver for you, through the tutorials that we will give you, you will develop these skills. But what does the MSc offer to you is an extensive link to the industry. So we are in contact with lots of companies in London or throughout the world, like World Bank, which they're either in the structural engineering side, or they're in catastrophe modeling or disaster management. Some of these guys will deliver some of the lectures, they will give you seminars, and some of them will support your research project in terms of dissertation in the MSc thesis at the end of the course. Some of these will be supervised by the industrial partners that we have at UCL. We also have a strong research environment due to the close connection that we have with our research team called Epicenter. We will talk about Epicenter a little bit more as well. So that makes sure that all of the lectures that we deliver, all of the courses, all of the tutorials that we will give you are up to date and they're state of the art of what research currently is looking at. We have a fun field trip to a recent earthquake area. We will talk about that more, and there are always several social events and parties as part of the whole MSc project that you have. I'm sure some of our current students and our alumni will be talking about that. This is some of the rankings that we got from the postgraduate thoughts experiment survey. Experience survey, sorry for the title, which is an independent non-governmental organization which each year assess the MSc projects, MSc programs which are offered in UK. And we're lucky, or we are among the best MSc projects programs in UCL, which are more than 290 programs. And for the last 3 years, we have been ranked at some of the top MSc programs that UCL offers. We have been assessed in terms of satisfaction of our students, as well as the quality of delivery in terms of teaching and learning, student engagement, assessment and feedback, dissertation, organization and the management of the program itself, learning resources and support services, as well as the skill development that we discussed. I'm not going to talk about these comments that some of our students have given through this survey, but I'll just leave the screen on for a few seconds so you can read some of the comments that they have given us. I'm not going to say we're amazing.
But we are. Or we pretend to be.
Yes. So yes, our students are very nice to us, so they give very good comments. But you do this MSc of earthquake engineering with disaster management in order to either find a better job or you want to learn a new skill. So we have to tell you what is the career that you can follow after learning this skill and having this master's degree. So you will be a new type of global earthquake engineer, which can take a complete approach to earthquake engineering as well as disaster management. So those of companies which deal with engineering sector, like civil, structural, and geotechnical engineering is always open to you. I always say that an earthquake engineer is a better structural engineer than a structural engineer, because you will see another aspect of engineering in terms of extreme loading as well. On the other side, there's an opportunity for you to enter the areas which require a unique knowledge that you have in terms of earthquake engineering and risk assessment, risk management, and mitigation. These industries, which we will talk a little bit more about them, are the insurance industry, the disaster management and relief, as well as non-governmental organizations which are in disaster relief, working in disaster reliefs, the NGOs over there. So, as you know, UCL is located in the center of London. We're lucky to be surrounded by some of the world-leading consulting and construction firms. For example, Arup, which has made the Marina Bay famous hotel in Singapore, WSP, which was the contractor of London's Shard, or the One World Trade Center in New York. So literally all of the world famous multinational companies, their offices are located in London, and we are lucky to have connections with them. So there will be seminars, there will be talks, and supervision of research projects done by these industrial partners as well. On the other side, I mentioned about the insurance. So the center of world's insurance is London. So City of London is the center of finance and insurance district of the world. Lloyd's Register, Lloyd's of London, is located in the City of London, which is a company which deals with insurance for the last 300 years. Because of that, more than 84 syndicates which underwrite insurance are located around it. They do insurance from like shipping all the way to all types of transportation, as well as disasters. So the natural disasters comes as a very important part for every one of these insurance companies. They really need earthquake engineers and disaster manager engineers in order to understand these risks and in order to mitigate. So the skyline of London, those fancy buildings, all of those tall buildings are either owned by operated by all of these insurance companies. If you're a fan of football, I'm sure you have heard of Aon, which is the sponsor of some of the big football teams, or Willis, Power Watson. These are some of the most famous insurance companies in the world. So I will hand in now.
So hello everyone. As I said before, I'm Carmine Galasso. I was the program director until a few days ago. I just want to go back on what Arash just said about insurance, because I guess many of you may not be familiar and may seem a bit unrelated why structural engineers need to work with insurance. So actually, before joining UCL 5 years ago, I was working in one of those companies in the US, in San Francisco. And the idea is that you can buy insurance, for instance, for your house, for any type of natural disasters. For instance, in the UK, it's compulsory to have a flood insurance for most of the residential buildings. Now, the issue is that while you buy insurance for cars, you can just look at historical accident in a given area. So, for instance, if you are from where I'm from in Italy, Naples, your insurance is crazy expensive because there are a lot of accidents and so on. The problem is that when we deal with natural disaster, you cannot really look at historical data, because fortunately, you don't really have many tsunami, you don't really have many earthquakes, you have quite few floods in Europe, but still, I mean, those historical events are not enough to produce, models on which, for instance, you can decide how much somebody should pay for their insurance. So what you can really do is to build what we call a catastrophe risk model, which is a simulation-based model. And within these models, really there is a need for structural and earthquake engineers to help for what we call the vulnerability. So how buildings basically respond to this different type of loading coming from seismic, coming from flooding, from wind. And now talking about the structure of the program, so we really try to cover this particular aspect of risk modeling and catastrophe risk modeling. I'll start actually from the options, because within the options we have a course called exactly catastrophe risk modeling, if you see down in the screen. And I think we are the first university in Europe, I'm pretty sure, and possibly the second worldwide that offers such a level of course, which is delivered from industry and 50% from academics. I'm strongly involved in this particular course. So that's really a unique selling point for this program that, again, I don't think any other program in the UK, definitely, and possibly in Europe, offer. More in general, so we have the structure of our program includes 8 different, so you have to take 8 different modules, courses. 6 are compulsory, meaning that you have to take those in the top, on the top of the slides. And they are pretty much with a strong focus on basic structural engineering knowledge. So you have introduction to seismic design of structures, so dealing with new structures, in particular reinforced concrete structure. You have advanced seismic design of structure, so dealing with more advanced topic, and in particular with steel structures. We'll be looking at structural vulnerability and resilience, so designing a new structure maybe easy if you have very good building codes and very good knowledge. But what about existing structures that have been there for many centuries and maybe they are very vulnerable to natural disasters, in particular to seismic loads? So how we can assess them, how can we make them better? So how we can do, for instance, retrofitting. Geotech and earthquake engineering. So again, everything we do is with strong focus on buildings, but again, also of course, the soil, structural interaction, the foundation play an important role. And so the geotech and earthquake engineering module will cover that. Structural dynamics, a bit more theoretical, and again, very much applicable, not just to seismic loading, but for instance, also to wind. So with very, very similar equation, very similar tools. And again, this unique module, seismic risk assessment, where you build a small risk model for a city in Italy, usually, or in Europe. It changes year by year, where we build this kind of model that are used in insurance, where basically we go from the fault that produces an earthquake up to this how the structure respond. But then the problem is that when you talk to stakeholders, to people that are not really structural or civil engineers, they don't really understand what structural response means. They don't really understand what an earthquake producing a displacement of the roof means. So the idea is that we always want to convert this information in something that people can understand, so in money. So if we can say that because of that earthquake, there is a loss of 1 billion and 1,000 people will be killed, luckily, there is a probability, a likelihood that 1,000 people will be affected. So that's something that everybody can understand. So really, in seismic risk assessment, but also in the catastrophe risk modeling course, we try always to also do the final step that, again, in many other universities usually doesn't happen. I mean, so really converting what is very technical, very engineering focused to something that, again, any stakeholder can really understand and can make a decision based on this information. There are two optional modules. These are just some examples. We are very open in general. If you say, one of my two options, I want to take, something from history or something from, Spanish. With some discussion and understanding the motivation, we usually are open to make sure that, you can take really any two options definitely within the department, but also within UCL. So that, again, the 6 compulsory modules are there and there is not much that we can do. So you necessarily need to take those. But then on the option, again, there is a lot of discussion in the first week, in induction week, where we can, decide your best also based on your career perspective and your aspirations. And there is at the end a final project usually. So the way it works at UCL, there is a, so this is just you can put faces to who is going to teach different modules. So the way it works at UCL, we have a first term that usually starts in September. The first week is induction week, where we basically meet each other, we know each other, you'll explore UCL in London. And usually it's the first term one ends in December, that's before Christmas. Then there is a second term from January to March, so usually until before Easter. And usually you have 3 and 3 compulsory in each term, and then ideally you can take options 1 and 1, but even, for instance, if you prefer to have a light term 1 and maybe a heavy term 2, you can decide to choose 2 options that are both offered in term 2. Then you have a revision period in April, pretty much during the Easter period, and then May is the period where you have most of the exams. So some of the courses that we offer, they don't really have an exam, they just have coursework that you do during the course itself. For instance, the seismic design of structure, the one that I teach, is only based on coursework, so you need to design a structure, and there are different pieces, different components that are assessed during the module. Same for seismic risk assessment, but other have a final exam that usually is in May. And then soon after the exam period, from June to September, you will work on your final project, your final thesis. It's 3 months, so it's fairly short time, but it's a very intense period where typically you will only work on your research project. And within these 3 months, we also have a 1-week field trip, where as Arash said before, we'll go somewhere in Europe. And again, in the last few years, unfortunately, we always went to Italy because Italy has been hit by a few large earthquakes in the past few years. So we spend a week there to basically see in practice what we've been studying for the past 8-9 months. And again, these are so the final research project, again, as I said, is from June to September. We have, as I said, as Arash said before, we have a lot of ongoing collaboration with industry in London. within traditional engineering, consultancy, but also in catastrophe risk modeling insurance. So we typically do some of those projects in collaboration with the final project in collaboration with those industries. So when you will be allocated to an industrial supervisor, and during the 3 months you can spend some time in one of those companies. We are now in discussion. These are some of the companies that, again, we have already very active partnerships. We are also in discussion with a few more others, for instance, AXA Excel, which is again another insurance and insurance company, is in discussion with us to set up some formal agreement for having, for instance, master project and internships after the master to work with them. There are few examples, and again, industrial project, but we also offer very heavy research projects. For instance, Kiran is here in the room. He will be involved during summer in a research project funded by the British Council looking at multi-hazard risk and resilience of historic building in the Philippines. So we'll be traveling there together with other people involved in the project. We'll do data collection, and then this project will pretty much will be around that research project. Here on the screen, you can see some example again of past projects really covering all the area. The one on the left side here is with Rumble, engineering design consultancy, so pretty much very structural engineering focus. The one on the right side was in collaboration with the University of California, Davis, where the students spent a month out of the 3 months looking, for instance, how we can quantify casualties. So combining both structural engineering and non-structural engineering knowledge. The possibly nicest and funniest part of the program is basically, I think it's a great learning experience. It's the field trip that we do in here. So usually between June and July, has always been in June. This year will be in July. A couple of years ago was in September. Where basically again you really will have full days, a full week of visit to damaged building to understand, what you have been studying on notes, what actually looks like in practice, but also looking at reconstruction, retrofitting, and also recovery, because most of those communities again will go there and also not just looking at buildings, but also really talking with people, with civil protection, disaster manager, and understanding all the recovery process and see what are the challenges and how we can address those challenges. And again, as said in the slide, a lot of fun and great food. So usually we get 1 to 2 people. Again, as said before by as Arash said before, so we have a strong link with our research group, which is called Epicenter. Epicenter is an acronym for Earthquake and People Interaction Center. And the idea is really what Arash said at the very beginning. We want to look at natural disasters, in particular earthquakes, not just from the civil and structural engineering. We can do that, and we will do that in a very, very good way, very advanced, very state-of-the-art way. But we also want to see the interaction with people, because again, you can have the safest structure or the unsafest structures, but then what about people that are inside? So really, we try to work a lot also with people in social science, in psychology, to understand, what is the perception of risk, how people are prepared toward risk, related to natural hazards, and so on. So our research group really involved people from all these backgrounds, statistics, remote sensing. So some of them, again, there are no formal modules. As I said before, the program is pretty much strongly engineering focused, although there are optional modules from other disciplines. And again, there are several, almost every week, seminars from people from different fields. So it's a really great research environment. We are quite a big group. Here you can see some of the faces. And we have a big research group with 28 PhD students that will be your teaching assistants in most of those courses, your course supervisor in thesis. So really there is a daily relationship, not just with the academic staff, with the old and boring professors, but also with the young PhD students and researchers that will really work with you on a daily basis. Again, Valentina is a good example of many of the activities. We pretend to be the largest earthquake engineering research group in the UK, because I know it's online, but I'm kidding. Anyway, we have a very strong research portfolio, so very, very strong, about 8 million. That's not the most updated one because we've been very successful in the last few months with a few recent research projects. And really, as you can see in this slide, we try to work again with a lot of industry from different fields, with NGOs, but also with universities all over the world. We have, for instance, a recent partnership with the University of Naples in Italy, which I would say is the largest and strongest earthquake engineering research group in Italy, for instance. And so we have this official memorandum of understanding, this official partnership, and we do a lot of activities with them, including again final projects, experimental activities, and so on. These are, so when I started being the program director for this master a few years ago, there were only 7 students. Valentina was. Actually, I forgot to say that Tarash also was a student when I was not even here, because you can see how old he is. But the program has been growing, has grown year by year. So there were 7 students in Valentina here. The year after, we were about 10. And then 2 years ago, we were over 20. It's not just students, but also academic staff. And then now we are constantly around 15, 20 students, which is our optimal number because we want a small number of students, so typically not exceeding 20. 20 is really the largest capacity that we want, because we really want, I mean, all the positive feedback and all the amazing stuff that Tarash was telling you about is really because there is a small group of students, and we really want to work together on a daily basis and focus and really. So the student satisfaction for us is one of the main objectives together with all the more formal academic. All numbers are very helpful in this regard because really we can work together and be a very strong partnership with student and staff. More boring and admin information, and I don't need to go through them. You can find them on the website. We'll share those slides, and also again you can see a recording of this presentation. So about the tuition fees, the entry requirements. So this program has students really from all over the world. Kiran is the only one coming from the UK and is a minority, not even from the UK actually. You are not even from the UK. I have been for many years in the UK, but really we have students from all over the world. A lot of students from South America, typically from earthquake area all over the world. So we have students from Italy, we have students from South America, Greek students, a lot of Chinese students from all over China. From the more Wenchuan seismically active area to the more Hong Kong, Shanghai, so the less seismically active area in China. So it's a really international program. That means that entry requirements can be challenging. So again, you can see some formal guidelines on the website by putting your country of study. But again, we are very open to discussion. So if you are not sure, if you think that something, these are just standard information that have been. But we are very open to discussion and also again to really look at your CV. So feel free to email myself, Arash, and we can start a discussion. We can have a call and discuss more about what are your aspirations if this program is the right one for you. There are some videos we didn't put in the presentation to make it too heavy. We have a Facebook page of the Epicenter research group and also one for the program. The one for Epicenter I would say is a bit more updated. So you can see some of the videos, including videos and photos from the field trip, some of our former students and some of our alumni talking about the program. So feel free to join, and again, feel free to contact us if you have any question. Yeah, just some links. I'm sure you are already, if you are at this stage in this virtual open day, you are possibly. Yeah, that's pretty much everything for us. So now it's your time to ask questions. And again, we have quite a few minutes to ask questions, but it's not just today. From now to September, when we hope to see you here, feel free to bother us any time. They know. So again, same for you, even if you are not here physically, feel free to email us, call us, and we are happy to help you and support you. Thank you.
You want to talk about your experience just briefly, and then
yeah.
launch some Q&A sessions, so you can still record that.
Yeah.
And then you can pull up the screen with the Q&A that might
Yes.
be good. So the students who logged in can sort of hear why you decided to choose this program and
Yeah.
how it's helped you.
That's a great idea. Okay. So I'll pass to Valentina first.
So hi everyone. As I said, I'm an alumna of the MSc Network Engineering with Disaster Management, and I belong to the cohort of Carmine when Carmine first joined as program director. Being at UCL led me to really understand the evolution of this master from that very first small group of people to this, let's say, bigger family, which is today. And I can say that most of the people in my year are still around as PhD students. So don't just consider the option of going out from UCL, because it can become a very good place where to stay and continue your academic career. So I highly suggest you to consider also the option of staying here and become an academic. So that's all from me, and I can pass it to the two students of this year.
Hi everyone, I'm Kieran. Well, the reason for me joining this course was because of my background. I was working as an engineer with a post-disaster reconstruction project with the UN. And if this is a route that you want to pursue as well, I think this course is quite good, because what I experienced working with the UN was that I used my engineering skills about, the job was 80% engineering skills and then 20% soft skills, international development skills. And here you kind of do get a good balance of those. So I was able to transition from my previous role as an environmental engineer now to a structural / earthquake engineer. And the second thing I think is that this course is quite good because, as the guys were saying, that it's a small cohort, usually around 15 to 20. You do get a lot of face time with the lecturers, and also the PhD staff or PhD students here really do help you as well whenever you're in trouble with some of the coursework. So it's quite different to being in, say, the general civil engineering masters where there's 200 students or something. It's ridiculous. But yeah, that's me. Michael?
Hello everyone. I'm studying in UCL for this EDM program for around 1 year so far. I think UCL is a very excellent place for study, which is completely different from my former universities. When I could give you an example, when I come into the main entrance, getting to the main entrance of UCL, when I see the portico, the very historical, brilliant building, then I would be energized for the whole day of studying here, either from the lecture or self-learning. There's another point I want to compliment here in UCL, which is the student well-being service and support. No matter where you come from, no matter what you encountered, what issues or difficulties you encountered within your study, no need for you to be fearful of them. You just try to find support through the student well-being service and support. Then most of the issues you encountered will be solved, as well as the staff. The well-being staff will endeavor to coordinate your academic progression with the department as well. So that's not a problem for you at all. I think UCL is trying their best to guarantee academic environment, the learning environment, as fair as they can. So that's pretty good.
Thank you, guys.
I'll stop recording now, and if you have the Q&As.
Yes.
So we've got a few questions already.
Yeah, that's great.